it will make the DevOps engineer's job will be very difficult. So that's where IAC tools are very popular among DevOps engineer. So for that, we have already seen how Ansible, via Ansible, we can automate the infrastructure. So Terraform is another IAC tool, infrastructure as code tool. We can completely provide an infrastructure as a code via Terraform. So it is implemented by HashiCorp technology. So it's a open source infrastructure only. So it helps in automating the complete data center by using just easy human readable format. All the terminologies, everything will be very simple, just like how it was in Ansible. So what are the benefits of Terraform is, so through Ansible, like it's a configuration management tool, but Terraform also does orchestration, like it will create a complete infrastructure, and we can also destroy the infrastructure using Terraform, and it will manage, it will have a state of the infrastructure that's been created. So it's not only doing configurations, it's a orchestration tool also. So and we have CloudFormation stack in AWS, right? It is also similar to Terraform only, but CloudFormation stack we can use only with the AWS cloud provider, but Terraform, it supports all the providers such as AWS, Azure, and Google Cloud Platform. So it supports all kind of providers, and we can make use of it. So it's easily portable to all the cloud providers also. So in the that language, whatever the language we are using in Terraform, it's also very simple, and it's called HashiCorp configuration language. So these are the Terraform core concepts, rather concepts. We call it as a terminologies. So inside Terraform script, each Terraform script will be ended with like .tf. In Ansible, we will create a playbooks with .yml extension, right? Like that, here we will create a Terraform scripts with .tf. So inside that Terraform scripts, these are the common terminologies and concepts we'll be using. So we will use variable. Variable is an attribute. So inside that variable block, we can provide our variables, and provider is nothing but the all the cloud services, like AWS is a provider, and GCP is a provider. So in Ansible, module we use, right? Module will be shell, or module will be EC2. Like that, here we need to first mention what is the provider. So for our case, like we can we will mention like AWS. And module, it's kind of an folder with all the Terraform templates, where like all the configurations will be defined. And whenever we run a Terraform script, it will create a state for the infrastructure what just we created. So the state will have complete configurations of the infrastructure, and what are the modifications done, everything will be in the state that we will show in the demo. And resource, so once we provide the provider, right? For example, like if we mention the provider as AWS, and if we want to create an EC2 instance, then we have to it will be a separate block. Resource is a separate block. We have to create a separate resource for EC2 instance. If we want to create any VPC, then that is a resource. If we want to create any subnet, or whatever the EBS volumes or S3 buckets, so all these are the resources under the provider AWS. So resources is nothing but the whatever the resources available for that particular provider. This is but in Ansible it is different, right? So we can just mention the module as EC2, and under that we can give the task names. But here whatever the provider we are giving, based on that we need to define the resources, and we can give the all the configuration values. So also here, like, yeah,
కొంచెం స్లోగా చెప్పారా? పాయింట్స్ బాగుంది, కాకపోతే
What was that, Rani?
Yeah. See, can you explain slowly? We can get points, right?
Sure. Yeah. So, yeah, please feel free to interrupt me like whenever you have a doubt. Um, yeah. So I have told about
Explaining about the
variables provide.
provider have to define the resources something.
Right. Until resource I have to. So output value, like they have a Terraform, they have a attribute called output, and for it's like a function name, just like if you are using C++ or Java, and you are writing some function, and we can expect some output from calling that function, right? So just like that, in Terraform also, if you are creating an EC2 instance, then we can expect a output, like we can define output. I want the IP of that instance, or I want that name tag of that instance. So they support this option also. So we can provide a output attribute, and inside that we can define what we want, and when we run the Terraform script, that output will be displayed. So that is very useful. And plan and apply comes under the parts of Terraform life cycle. I will explain here. So this is the Terraform life cycle. It has 4 important stages, like init, plan, and apply, and destroy. So now we have written a Terraform script which will create a complete infrastructure. And what are the steps we need to do, right? First, we have to give the command Terraform init. So what it will do, it will initialize the working directory. So we have to create a directory, and inside that we have to put all the .tf files. If we give Terraform init inside a directory, right? So it will execute all the .tf files inside that particular directory, and it will initialize it of the all configuration files. But in Ansible, right, we can mention the playbook name, like Ansible playbook. I just want this particular script to be executed. So we will give Ansible playbook and that playbook name, right, .yml file, right? But in Terraform, it's not like that. Inside, we can't give any particular script name. Inside directory, we need to execute Terraform init, and it will execute all the .tf files. If you want to exclude some files from the directory, then there is an command inside command for that, like exclude or something, or we need to put that .tf file inside some other directory, then it won't be executed. But otherwise all the .tf files will be executed. So that will happen in Terraform init. And Terraform, next is Terraform plan. We need to give, so now all the configuration files are initialized. Now next we need to give Terraform plan, and now it will create the actual plan.
Yeah,
Step.
I'm going to interrupt you. So,
Sure.
yeah, is there any reason that, or is there any use case that a module, nothing but a directory, right? And will have a multiple main.tf files?
Yes.
Okay.
A module I haven't explored yet,
Okay.
Vishnu.
Okay.
Resources provider and all I have used, but module I just read what is the module, but I haven't explored it yet.
Oh, okay. Yeah. Okay. Yeah. No problem.
If you know, like you could explain now.
Yeah. So the module, nothing but, let's say you create a folder and you create a main.tf and output.tf and a variable.tf inside
Yes.
a folder, right? So that folder will be called as a module. Basically, you are trying to achieve something. You are trying to achieve, for example, create an EC2 instance, and you have main.tf. For that's the main Terraform file to create infrastructure, and you have a variable.tf, that's var.tf, and you will provide any variables that you wanted to provide, or you don't have to have variable.tf file. Basically, if you are providing the input variables inside your main.tf, you don't need that variable.tf file, right?
Yes.
And output.tf it's not a mandatory. You can have it or you cannot have it, but it doesn't matter. But So for each module, that means for each directory, there should be only one main.tf file basically. So if you have a multiple main.tf files, right, it will try to execute the multiple main.tf, but I wasn't sure basically, and there should be a conflict basically, because what you are trying to achieve exactly is a question mark basically. So yeah, I would have to look into that, but just wanted to see, like, is there any use case that you have explored or not?
Okay. Not yet, Vishnu. I'll
Okay.
explore it.
Okay, yeah, that's completely fine. But did you understood that module, Priya? Did you understand that module thing?
Yes, Vishnu, I got it. It's just like any other language, we can have only one main.java or main.c file, right? Like that, here also we should maintain only main.tf. But yeah, it will definitely result in a conflict if we have multiple main.tf files. So with the help of module, how we can achieve that, I will explore it.
Okay, yeah. Yeah. You, Priya.
Yeah, and Terraform plan. If we execute Terraform plan, then it will create a graph of what are the stages, what is the how we are going to create the infrastructure. So those steps will it will create a graph like thing, and it will display us. This is the plan that's going to be executed for the infrastructure which we configured. So and that second stage, and now we will apply if we are fine with that plan, then we can go ahead and apply Terraform apply. Now it will based on the plan it has created, it will create a infrastructure just defined as the plan, and it will create also a state. What EC2, if we are creating EC2.tf file, then it will create a terraform.tf state. So what is the tf state will have all the configurations for the right. For example, like if you are creating an EC2 instance, when we apply the Terraform apply command successfully, then it will have a tf state file, and it inside that it will have all the details of the EC2 instance. What is the VPC, subnet ID, name, and region, AMI, all the details inside that tf state, it will be there. And yeah, that's it for creating a Terraform. And now a EC2 instance has been created, and now you want to destroy the infrastructure you created. So you don't need to do it manually by going to the management console. Just you can go into the Terraform directory, and you can give a Terraform destroy. Whatever the plan you have created will be completely destroyed. For our example, EC2 has been created using Terraform apply. Now that EC2 instance will be terminated if we give Terraform destroy. So this is the Terraform life cycle, and so this is the components of Terraform. So we have two components, Terraform core and providers. So as a DevOps engineer, first we need to write a .tf files, and first components is Terraform core, right? So it accepts two kinds of inputs. One is .tf files, and another one is .tf state. So if you are creating the script first time, then we won't have infrastructure first time, then we won't have this .tf state. But if you're doing once it's been created, if you're doing again the Terraform apply or in the future, then it compares this tf state also. So for Terraform core, it accepts the tf file configuration files as an input, and a .tf state file also as an input. So and now Terraform core, then it will pass into provider. So inside the Terraform .tf file, we will mention the provider, right? So it will install all the plugins the needs for AWS or Azure or whatever provider we have mentioned. It will install all the related plugins. Then only we can use the particular provider resources. So Terraform core and providers are the two important components of this Terraform. And that's all pretty much what I need to share about Terraform. Now we can see how to install Terraform and how to create an instance. So yeah, so this is the instance I have already run. Terraform, it's already installed here. So I'll create a new instance. Why it says pending? Usually it will be like initializing.
It's not there yet. Yeah, I think the next state will be initializing basically.
Okay.
Yeah.
Yeah.
You see that right side?
Yeah. Yeah, until that I'll show the existing Terraform scripts I have written. So in this, I have already installed Terraform. You can check that version via Terraform version. So it's already installed. So I have created a directory called Terraform test. And inside that, I have written this .tf. And see, this is the tf state files I was telling. So when you apply Terraform apply command, this will be created. And when you destroy the infrastructure, backup of that infrastructure will be created in this one. So if you just want to see what is inside that, so it will show all the I will maximize this. All the informations regarding that instance. Everything it will store in the tf state file. Okay, we just need more minutes.
Try to connect it, maybe.
Okay.
Select it.
I'll exit from here. Okay, yeah, it got connected. So let's go and install Terraform. So here I'm using package manager as yum. There are other ways also, like we can download the binary and we can install it, but it's the easy way. So before that, let's check Terraform is installed already or not. So if you are doing tab and it's not coming, then itself like we can say it's not installed. And
Yeah, that's the one command from sudo
okay.
to all
Yes.
the yeah.
Yeah, now Terraform is installed and I'll create a directory. Now I'll create a file. Now I'll just create a simple file without creating any variables or something. So first we'll mention the provider, AWS. So inside the provider, access key is an attribute. So I have the attribute key here already. So you need to get that EC2 users credentials. Unlike Ansible here, that indentation and all, it's not really matters. So it's really easy. And also in the provider, we need to mention the region. For me, it's US East 1. And now we should use the AWS Instance Resource. We are going to create an instance. So this is the resource name, which is predefined. And now we are going to define a name for this. Like this will be called as a block. So identify this block. We just need to give our customized name. So I'd say test. Yeah, test instance.
Priya?
Yeah.
We are not mentioning any secret key access key in Ansible, right?
No, in Ansible also we will mention it. Usually by giving AWS configure command, we don't need to mention. But if you're not configuring via AWS CLI, then we need to mention in both Ansible or Terraform. Yeah. And first thing, it's AMI. This is also like these attributes also predefined, so we need to use the correct name.
Is it that secure, Priya? We mentioned Ansible playbook if it is secret key access, is it secure?
Yeah, in Ansible, we will use Vault to encrypt that file. Here, actually, I have tried using a different var.tf file and exporting, using that variables inside this. But I haven't explored that HashiCorp vault yet. So, but there is a way, I think.
Yeah, it's a
Yes.
secret free actually. So,
Yeah.
HashiCorp Vault, it's not Vault actually. They have a same predefined attribute, like you have like a AMI resource like that, right?
Mm-hmm.
You have an attribute called secrets basically. So what it will do, it will automatically hide the secrets. Even in the output, it won't show that specific secret actually. Let's say you are generating access key and secret key or whatever. If you are trying to create an IAM user, right, using Terraform, and access key, secret key will be generated. Even you don't see that in the logs, even the output, you don't see that actually. But that's like a advanced level of Terraform, so that's fine.
Okay. So, AMI. So here the only thing we need to remember is we have to provide everything inside this double quote. And what are the other required? Yeah, instance type. And these are the basic attributes we should give for creating a EC2 instance. Subnet. after creating associate public IP address.
Priya, sorry to interrupt you. I know it is a basic question. The script is Terraform script, right?
Yes, yes.
Okay, yeah. Just want to make sure.
Yeah, so whatever you are saving with the .tf files, right? So
That
all
is, yeah. Okay.
so now we have created the Terraform file.
Mhm.
Everything is ready, and now we will initialize this. First command is Terraform init. So if you have any errors inside the in the initialization stage itself, it will tell. Right now it got success, and next is Terraform plan. So here it will in detail it will tell you like what are the configurations it's going to provide to that infrastructure. So instance type, AMI, that and all only we have given in the script, right? So only that is assigned. After that is everything is every attributes else is not right now it's not known. We have given the subnet ID, so that is showing here. Yeah. So yeah, I'm fine with this Terraform plan, and now I will go and apply it. So now we have to say yes, then only it will create an infrastructure. So yeah, this is the resource it is using, and this is our name. I mean, it's not name of EC2 instance. It's just our block name. Yeah. So it got created, and it's giving us the instance ID. So now if you look at it here, it TF state got created.
Priya,
Yeah.
can you tell about that elapsed? It's showing 10 elapsed, 20 elapsed, 30 elapsed.
I think for every 10 seconds, they are giving us the what kind of stage it's in. So just the logs, if it is failed, then they will show. So for every 10 seconds, they are telling the user. Is that correct, Vishnu?
Oh yeah, absolutely. So they are telling every 10 seconds, they are giving us an update basically. The script is giving us an update.
Yeah.
Okay, is it for every 10 seconds, Vishnu, or we can define some time like that?
No, so the script, it's by default basically.
Okay.
But if you want, let's say this instance is created, right? And you, after instance is being created and you need some time in order to come that instance up, right? In order to SSH into that instance.
Yeah.
That time you need to provide wait time inside a script, but this is default.
Okay.
Let's say after one task and I wanna wait for certain period of time, you need to provide that wait time inside a task. But this is
I got it. Yeah, in Ansible we said wait for yes.
Yeah, like that. But here this is like a Terraform default, Harshikap default.
Yeah, got it, Vishnu.
Yeah, and yeah, so now the Terraform, all the other attributes got applied with the default values. So now if you look at the state, AMI got we mentioned, and the ARN, availability zone, and CPU. So everything got assigned, and this is the current state of that infrastructure. we can go to our console and check whether that instance got created. Yeah, so it got created. So this is the Terraform instance we created using that automation script, and it's in initialization status. So now like we can go uh, manually inside this instance, and if we want to edit some details, like we can give tags. So yeah, we'll try that. What the instance name I wanted to be test 1 2 3. So I'm adding the tags here manually, not from the Terraform script. So still an initializing. That should be fine, I guess. So we have made made the change, but if we check the previous TF state, so yeah, the tags are not applied because it was created previously, right? So we need to refresh this TF state. So for that we have a command terraform refresh. What it will do is basically the actual instance, it will go and look, and it will compare the existing TF state, and if anything is if it finds any difference between the current state and the previous TF state, then it will update the TF state, not the script. It won't update the script, it will just update the TF state. So now it has been refreshed. Now if we check the thing, in tags it's not showing. See here, yeah, we have created a manually, we have updated, right? So that's it's reflected here. So for that we need to give terraform refresh, but in practical, like what it is not useful, and we should not do that, because we are creating an infrastructure through code only, using terraform script. So we should not go to any we should not go to the instance and do any changes manually. Then we are losing the purpose of automating the infrastructure via code. So whatever configuration you need, we need to do in the configuration script only. So but I wanted to show you, like if we change manually, then this TF state will compare and fetch the difference, and it will up to date, it will update the TF state. But this is not the recommended way. So even if we like try to apply again the same TF script, means what will happen, we'll see. See, like because in the configurations we are creating one structures without the tag, but right now we have we have changed the tags manually. So it's saying in the configurations the tags are not there. So but we are now trying to apply the script again. So it will check the TF state, and it will check the configuration file. So these are the differences I'm finding. In configuration file you didn't mention any tags, but in TF state I have found this tags, and it's initialized with this name. So I'm going to be delete this, so that the warning, or that is the plan, it's going to be executed. And yeah, in the configuration only we should make any changes. If you are doing manually, then if you are applying the Terraform script, definitely it's going to be deleted. So if I say yes, it must be deleted. It will take some time. Why it's showing it's the same instance and okay, let's go and check again. Same instance ID. Yeah, same instance ID only. See, the tags are gone. It will take some time to reflect here. So this is how like it will keep the TF state and configuration file same as the infrastructure what we are trying to create. So simple cases like this, like it will not be clear why we need to update the configuration script rather than manually doing it. It will be seem something simple, but when we are creating a complex infrastructure and if you are doing anything manually, then it will create unwanted confusions. So what if we are automating a script infrastructure through some Ansible or Terraform script, then we need to make the changes inside the script only. It is the only recommended way. So yeah, that's it. Yeah, this is the simple Terraform script. So in another Terraform script, I have created a variable .tf another file, and I have used that variables in another file. I'll just show you how it's done. Which one? So until this, if you have any questions. It's not the one.
Have you deployed the Terraform? Actually, I think I didn't see the last step, the deployment.
Destroy, you're saying, or?
Deploy. You said that there are 4 stages in Terraform.
Yeah, it's not deploy, it's destroy, Raj.
Sorry, destroy. Yeah, sorry.
I didn't do it.
Okay. Oh, okay.
Yeah, let me do it. No problem.
Oh, okay.
So here we can give destroy.
Complete instance will be deleted.
Yeah, whatever the infrastructure you have created, right?
Oh, okay.
Yeah, it's done. Yeah, this is the one it got created. So now it's terminated.
Okay.
Yeah. So here inside the previous one, I have given the access key, secret key inside the provider itself, right? So we can make a use of the terminology variable also for declaring any variables. So here I have used a separate script for that. So this is the attribute variable, and this is the variable name. This is our choice, like we can give anything. And for each variable, we need to define what is the type. It's more of like a data type. So this data type is, we want it to be as a string, right? So string, and this is default. By default, what is the value? So that we should give here. So same as for secret key also, the data type is string and the default value is this one. So this is one data type. It supports multiple all other data types which are available in other languages also, like string and array, integer, numeric. All the data types are supported. So here I have used a data type as map. Here inside this, we can have multiple values. So if you're using type map, then inside the default value, map is nothing but a collection of more than one value, right? So here string, we can give only one value for this variable. But if you're using a data type as map, AWS properties, I have assigned this variable name. So this AWS properties, if I assign this data type as map, then I can give a lot of variables inside this. So it will be.
So here only we can.
Key value, like what it is to map usually.
Sorry, could you?
Map will be stored as key value.
Yeah, secret key dot where dot secret key, we can access like this.
No, I'm telling
I'm
the type data type map will store like key comma value. Deep like region is the key.
right.
East one is the value.
Yeah, exactly. So inside the actually in this itself, I mean inside the map itself, we can give the access key and secret key also. But I wanted to show you like how we can give a variable in a as a one single data type, or how we can make a use of map data type. So here,
only we can here only we can give the tag value also, right? Tag name.
Yeah, here also we can
We
give
can mention.
yeah.
Mm-hmm.
So region, AMI, and instance type, public IP, whatever the properties you want to use inside the AWS instance resource, we can mention here. So now I will show you how I have used this in the main.tf. I didn't name it as a main.tf, but this is where we are telling what provider and what resource need to be used. So provider is AWS. So this is the attribute. So for this, I need to get the value from the variable.tf. So if you look it in the other languages, right? So I have worked in C++, or you might have worked in Java. So we need to import that variable.tf file. But here in Terraform, we don't need to do that. Because inside a particular directory, we are executing a Terraform, right? So automatically all the files are like all the files are known to each other. So by giving just var dot access key, that will be imported here. That value will be replaced here. So var dot secret key, it will be replaced here. So I'll show you that one. So how we need to make a use of this variable defined is whatever the variable you need access, you should give var dot. That is the predefined method. So var dot and our variable name access key. So now this will be replaced by this default value var dot secret key. Now this will be replaced with this default value. So if you are using just string type or numeric type, we can give like this. But if we are using a data type as map, right? Inside map, we have so many attributes. So how we can use a map data type? So we should know we should do a lookup. Like in other languages, we will be using a struct or a class or something like that, right? So we will go to that class name, and inside that we will look up for the particular key, even in DB also. So like that we need to use. But here it's very simple. We don't need to remember any syntax or like that. Just we need to remember if we are using map, then we need to look up the key what we are using. So so yeah, region I have declared inside AWS props, right? So that is a map data type. So how I'm looking up, I'm just using the lookup predefined function, and inside that var.aws props, comma, this is the key I'm looking for, region. So this is the variable I'm accessing. Inside that, this is the key I'm looking for. So it will fetch the region value and it will be replaced here. And again, resource, I'm using AWS instance as a resource. So yeah, AMI also we have already given in the variable file, and we are just looking up the that AMI ID, and it will be replaced here. All other this is right, like AMI, instance type, associate public IP address. These are predefined attributes. If you are not using the correct one, it will throw an error. Like instead of instance type, if I used just type, then it will give me an error. Like this is the unknown attribute you have used for AWS instance. So these and all we need to know. We can Google it, but this and all should be from the HCL language. So yeah, instance type, public IP address, everything I have used. And this one tags, right? So here we can just use tags is equal to like that. But if we want to use name, if we want to use more than one tags, like in the while configuring the instance, we can give more than one tags, right? So yeah, so we can add tags until up to 50 tags we can add. So what those kind of attributes we can mention like this: tags is equal to name, and here itself we can add one more one. So for name, I'm assigning this. For OS, I'm assigning this as a CentOS or something like this. So whatever the tags, up to 50 tags we can add in here also. So that for that we need to define something like this. Inside a resource, tags is equal to open bracket and all the tags, and then you should close it. And finally we should close the resource block. So this is one way. And yeah, I was talking about that output terminology, right? So this is the output. So this is the attribute output, and this is the EC2 instance. It's our for our purpose. And what value I need? I need this AWS instance resource. From this resource, and I should mention my function name or resource name dot. I need a public IP. So once the Terraform has been applied, right, it will create all the attributes. So inside that, it will have a public IP row, or it will have a public IP value. So I need that public IP value. So if I assign this to value, once everything is done, the infrastructure has been created, I will get the output like this: EC2 instance is equal to this IP. I will get that value. So I have tried this already, but yeah, I'll execute it again. So since it's already created, it's showing the outputs. This is if you're doing it the first time, it will not show this one. Only after Terraform apply, we will get the output of IP of the instance, right? So since I have already ran this command, it's showing this output.
Any questions from anybody?
Yeah, Vishnu. See, Ansible also terminate. We are automated. We are using playbook and automate. We are doing automation and we are terminate EC2 instance, right? So same way we are using here also Terraform. We are terminating that instance, right? What
Yeah,
is the
but like as far as I know, in in Ansible, we need to go and write a playbook for stopping that instance. Like that's how I was doing. We need to write a playbook inside that. We will mention the instance ID, and for that instance ID, I will assign like state is equal to absent or stop. Then it will terminate it, right? But here you don't need another configuration file or a playbook to destroy the infrastructure whatever you created. Here we are using an infrastructure just to create an EC2 instance. It can get very complex, right? You can create an EC2 instance. On top of that, we can use any Lambda functions, or we can do multiple actions. And once everything has been done, we can also create a cluster and deploy Docker on top of that cluster. So once everything is done, then we all we need to do is just Terraform destroy. So all the EC2 instance creation, Docker, cluster, everything will be deleted. So that's the one biggest advantage I'm seeing in Terraform. I'm not sure in Ansible it's possible in that way. Is that correct, Vishnu?
Yeah, it's not possible. You need to write another automation script with Ansible.
Yeah, that's why like Ansible, we are telling as a configuration management tool, whereas Terraform, we are telling as an orchestration tool. We can actually manage the infrastructure, creation, destroy, everything is possible.
Yeah,
So
exactly.
yeah, so this is the output I got. So I got the output of IP, and if I go here, so yeah, it created another instance. So since inside the Terraform we have assigned the tags as Terraform EC2, right? So it's assigned the name also. Yeah, so these are the two ways we can create an EC2 instance using Terraform. Yeah, that's all I had, Vishnu.
Okay, anybody have any questions, any doubts? Okay, so Priya, I can clarify that module, and can you make me host actually? And I want you to destroy all your instances actually, including that controller.
Sure.
Yeah, let me share my screen.
Vishnu, someone asked that they couldn't able to delete the user group.
Okay, yeah, we'll talk about that. That's fine.
Okay.
Okay. Yeah, can you guys see my screen?
Yeah.
Yes,
Okay.
Vishnu.
So Priya, you created a folder, right, in order to add the Terraform files.
Yes, Vishnu.
That folder is nothing but is a module. Okay.
Okay.
And what the module is doing exactly is whatever you want that module to do actually. So you are building a custom module. You are using default attributes like a provider, like AMI, things like that, but you are building a custom module. This is a module. The directory that you created is a module. And you have a one main.tf file and one variable.tf file and one output.tf file for each module. Okay. And this is for EC2, for example. And I can create one more module to provision Lambda with Terraform. And I can call this module as a Lambda. And again, I have a one main.tf, one variable.tf, and a one output.tf. Okay. And there is a use case that I wanted to provision both of them at one place. Okay. I can create one more. I can create a global Terraform module. I can call it as like a global, let's say. I can configure one main.tf, and one global variable.tf here, and one output.tf, and I can mention module 1 and a module 2 in this folder basically. Okay, and if I execute this main.tf, right, and it is going to execute this module, especially this module. What we have in this module is we have a module A and module B. We define a module A and a module B. So there won't be any conflict, because when you execute this main.tf, let's say you mention module A first, it will execute this main.tf. Then if you mention module B second, and it will execute this main.tf. Basically, you are calling these two main.tf files from this main.tf file. Does that make sense, Priya?
Yeah, yes, Vishnu.
Now you guys understood how module works?
Yeah.
Okay. Let's try to. I'll show you very simple. Okay. Let's say I'm creating a I'm creating one EC2 instance. I'm going to create a module mkdir and EC2 TF. Okay. One lambda function mkdir lambda TF, and one, for example, data lifecycle manager. Let's see just examples. Okay. Data TF. Okay. And I'm going to build a Jenkins image. Let's see. mkdir Jenkins TF. Right. Now I can go to ec2.tf and I'll have a main vim main.tf. Right. Let's say this is main.tf, and I'll go back and mkdir, not mkdir, cd lambda.tf and touch main.tf, and go back data and touch main.tf and go back Jenkins and touch Jenkins.tf, touch main.tf. Okay, and I can come here. Okay, and now I want to use, maybe I can create one main.tf here. Okay, vim one main.tf. Okay, I can mention ec2.tf, ec2.tf. Roughly, this is not exact syntax. Okay, ec2.tf, something like this, and I can provide all the values, blah 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 here. Then lambda tf and Jenkins.tf, Jenkins tf, something like this. Then data tf, something like this. Okay, and I can have one variable, global variable file here, like a variable 1, for example, variable 1, variable 2, blah, blah, blah. Okay. Now, if I execute this, if I run Terraform apply here, it will apply, it will create these 4 modules basically. And if I do Terraform destroy here, it is gonna destroy the whole infrastructure. Let's say, for example, if I want to create only EC2 instance, right? I would go here and I would run Terraform apply, and it will create only this infrastructure, vice versa. Okay. Is that helpful? Any questions? Any comments? No questions?
These are these modules instances?
No. So the module is nothing but the predefined software. You are defining a software. You are building a software that
Package.
can create your infrastructure basically.
Oh,
This is what it is like basically. So infrastructure as a code, you're writing a code to create infrastructure, and
okay.
you're building a software to create that piece of infrastructure that you want. Okay.
Okay.
Any questions?
Vishnu, through Ansible also we can create EC2, all those things, right?
All those things, but we are learning Terraform here. Even manual also we can create all those things, right? And we wanted to explore multiple things basically. You know, because some companies they use Ansible, some companies they use Terraform, some companies they use CloudFormation, some companies they don't use anything. They want you to implement anything. They will hire you if we don't know anything. Actually, we don't know all these technologies, and we want your help to achieve some infrastructure automation, and you know, things like that. But we will have to know like what exactly happening, why people are talking about all these technologies. That's we are not comparing Ansible with the Terraform. We are learning another technology, HashiCorp technology here. And meanwhile, and we can use different purpose. Let's say if I wanted to make changes to existing infrastructure, I wanted to add tags, and I wanted to install some softwares like maybe Nginx or things like that. I can write simple Ansible playbooks. I'm not creating infrastructure. You could do it, but I can pick the better way. If I feel like, okay, I'm creating this much infrastructure, like creating Lambda, all those stuff, and I can write just one automation script to create and destroy as well. And I can create now, and I can test it, and after testing I can destroy it. And tomorrow if I want it, I can create again, I can destroy again with the same script. For the blue-green deployments, this is very, very helpful because you will be terminating the infrastructure. Each time when you deploy your new version of application into ideal environment, for example, if you have a, give me 1 second, let me clear this one. And if you have an identical environment, like this is your environment, this is your infrastructure, and this is blue infrastructure, and which is running version 1 application. That means, for example, Nike with men, only men, Nike men. Okay. Now you've created identical environment. Okay. You are calling this identical environment green, and you are deploying version V2, which is Nike men, and you included women. Okay. Now you tested it, and which is working fine without any issues. You're working fine, and you don't need this men, right? Because both are working here. You have updated version of your application up and running, right? You need to terminate this whole infrastructure. And how you're going to do that? You don't need to write an extra script actually. Even if you write an extra script, you're going to miss some components actually. Let's say you're going to miss, like, let's say I have a lambda, EC2, extra user, blah, blah, blah. I'm going to miss a component like a remove user as well, for example. Things like that, even if I write an extra script. But in this case, no. Whatever I had earlier to create this infrastructure, I'm going to run the same script to destroy this infrastructure and done. Did you guys see that benefit basically?
Yeah, Vishnu, before destroying, can you take a backup?
Before destroying, can you take a backup?
Yeah. For next time use or like that.
For your instances, you have that script. Next time, if you want something, you can run the script again.
Okay.
But Madhavi, this is the real-time scenario that we are talking about. And let's say you're paying for this infrastructure $1,000 a day, for example, in real-time scenario, right?
Mm-hmm.
And you're going to save $1,000 a day by destroying the old infrastructure because you don't need it, right?
Yeah.
And you implemented Terraform script to create an identical environment because you're using only this script to create any environment. Next time, now you destroyed blue environment. Next time, you create blue environment, but you're using the same script.
Okay.
Okay?
Yeah.
You're using the same script. I don't need a backup for this, but EBS volumes like snapshots will be taken. That's a different story.
Okay.
So it is not going to terminate any snapshots basically. You take snapshots, whatever the infrastructure that you create, it will terminate only that infrastructure. It is not going to touch other than behind that infrastructure.
Okay.
Okay?
Yeah. So in Terraforms also the same thing, right? The snapshots will be there, right?
Yeah.
Okay.
Any questions?
Vishnu, while showing the document, Priya explained, right? That time she destroyed that EC2, right? And after that, another script she wrote with a variable. And after that, another instance created with that script.
Yeah, because she created another module and she added some configurations, like she tried to explain us how many ways that we can write a module, like how many ways you can define your variables and how you are going to call your variables from variable.tf to your main.tf. And that is a completely different module basically. So first time she explained us module 1 and she destroyed the whole infrastructure by using this module 1. Then she created one more module called module 2 and she added more features like a configuration, like a variable file and the map configuration, all those details. And she created infrastructure using module 2. And I assume she destroyed that module 2, like infrastructure, by using the same module 2.
So basically this CloudFormation and Ansible and Terraform all are doing the same work, but each company is using different tools. That is what
we don't know that they could use the same thing for they could use the same thing. Let's say I wanted to create only EC2 instances by using Terraform. And other than EC2, let's say I need to provision a Lambda function, but I can use CloudFormation. And let's say I want to create an EBS volume, so I can use Ansible. We don't know that, right? We don't know that. They want us to work on something and we cannot tell them that, hey, I don't know how does that work, but I can write this one. We cannot tell them. They will ask us to, hey, I want you to write a Terraform to create an instance, and Ansible to create a Lambda, and CloudFormation to create S3. Okay, sure, why not? We can do that.
Oh, okay. Mhm.
Okay.
So these kind of things will happen in real life. Means all these three different tools they are using for different purpose like that.
Yes,
Vishnu?
yes. In the real time,
Oh,
it happens.
okay, okay, okay.
Yeah. For infrastructure creation, right? Like a building instances and that kind of stuff. Most of the companies they use Terraform, but installation of prerequisites like let's say you need to install Java and you need to install Node.js in order to deploy the application. For that kind of infrastructure installation of prerequisites, people use Ansible. And CloudFormation, maybe they can write some CloudFormation script to provision Lambda or things like that. But yeah, if you are good at one, and the second one will very easy. That will be very, very easy.
So Vishnu, in Terraform, you showed one example, right? You created 4 Terraforms, right? One Jenkins and 3, one for Lambda and 2 other things, right? Before destroying, can you take backup of those Terraforms?
So
As it is rework, right? Whenever I need those, I have to do it again, right?
Before destroy, you want to take a backup of the whole infrastructure. And then what is the purpose of destroying the infrastructure, right?
No, right now we are not using, right? For AMIs, it won't charge, right?
That backup, you can log in and you can take it. You can take a backup and you can terminate the server using Terraform destroy. It is not going to terminate that AMI that you created.
Okay, yeah, that's one.
Yeah, you can take it.
Okay.
Okay.
One more thing, Vishnu. If you applied like destroy, all the modules will be destroyed, or just whatever module we want to destroy, it will be destroyed.
You can go inside a specific module and you want to destroy.
Okay. Yeah.
That module will be destroyed. That infrastructure which is used, whatever the module that you use to create that piece of infrastructure will be destroyed.
Oh, okay. Yeah. So we have to go into that module and then give destroy.
Destroy. Yes.
Okay. Thank you.
Yeah. Priya, did you understand this real-time use case where we use Terraform?
Yeah, yes, Vishnu, I got it.
Okay. Ramya, any doubts? Ramya, are you there?
Yes, Vishnu, I'm good.
Okay. Madhavi?
Yeah, good, Vishnu. Yeah, thanks, Priya. That was a very nice explanation and showing with an example.
Yeah, thanks, Madhavi.
Any questions, comments?